Well, it's time to begin. Today we are going to, as you can see, cover rational equations, which we started yesterday. We'll cover absolute equations and equations with rational exponents. First problem we're going to work is the one up here on the board. As I look at this problem up here, first thing I have to do is I have to factor that if it can be factored, so I can find the least common denominator. Well, x squared minus 4x minus 5, that breaks down. Let's see, I've got a 1 and a 1 and a 1 and a 5. And because it's negative, I'm going to subtract the difference. So I get a 5, a 1, which gives me a 4. The 4 has to be negative. Sign of the biggest is there. So here are my signs. Put in the x's. So that means that that factors into x plus 1 and x minus 5. So if I look at that, I've got an x minus 5 there. I've got an x minus 5 that's a component of that last element. I've got an x plus 1 there, an x plus 1. So my least common denominator then happens to be that. So I take this problem, 3x, and I multiply it by the x plus 1, x minus 5. And it's over x minus 5. And I like to put parentheses around those. Equals a 2 over x plus 1. So I have to multiply this by x plus 1, x minus 5. Plus 2x squared plus 40 actually will factor a little bit into 2 times x plus 20 or x squared rather. And then I have to multiply that by the x plus 1, x minus 5. And it's over x plus 1, x minus 5 from this. Now we've got some canceling we can do. This goes into this once, into here once, and this pen isn't working very well. The x plus 1 cancels out this x plus 1. The pair of these cancel out the pair of those. So what I'm left with then is 3x times x plus 1 equals 2 times x minus 5 plus 2 times x squared plus 20. Okay? This gives me 3x squared plus 3x equals 2x minus 10 plus, and actually I didn't need to factor that after all, x squared, 2x squared plus 40. So I need to combine all of my terms. I want to put all my, well, let's just see what falls out. Let's simplify what I've got on each side first. I've got 2x squared and plus 2x. Okay, I'm checking these off as I go. And minus 40, or plus 40 and minus 10 is plus 30. Okay, over here, nothing I can do to those. So let's start taking stuff over to this side. All three of these by adding their opposites. So what I end up with then, this is all 0 over here as it's supposed to be. And here I get the minus 30, I get 1x, and I get 1x squared. Now I have to factor this. And that factors into x minus 6, x plus 5. Okay? Factors of 30, 5, and 6. Okay? Actually, I've got these signs backwards. Sign of the biggest has to be positive. So that's why they're this way. Equals 0. So that gives me solutions of x equals negative 6 and x equals positive 5. Now, one thing that I've left out so far is I have not done a domain check on this thing. What numbers can it not be? Well, it can't be, x can't be positive 5. And x can't be negative 1. So it can't be either of those two answers. So I compare that with what I got here. Here's a positive 5. I can't use that. So that one I eliminate. So my final solution then is x equals negative 6, or in set notation, negative 6. Funny looking bright braces there. Okay. Now, let's go back through what steps we did, because this is basically the last problem I'm going to do on this particular skill. We look at the denominators. If any of the denominators need to be factored to find the least common denominator, you do that. That's what I did over here. Okay? So I've got the x plus 1, the x minus 5 is what that common denominator, or what this denominator is made up of. Now, next thing, I need to determine what I cannot have, which I realize I did it at the end. Then the next step is to multiply every term by the least common denominator. Multiply out, distribute everything out, simplify it, and then most of the time you're going to have to factor again. Once in a while you might not have to, but you're going to have to factor or use the square roots property or something like that. Or maybe the quadratic formula. Well, anyway, this one did factor, and I got these two values. I evaluated that it could not be positive 5, so then I had my solution. Okay, now we're going to go into the other statements. These scribbles right now, they'll fill in the blanks in a moment. The skill that we're going to be working with right now, of course, is absolute value equations. Now, what this says, if the absolute value of something equals some number, then you can have either a positive answer or a negative answer. Example of that, absolute value of -5 is 5. Okay? Because whatever this is, it turns into that. Likewise, the absolute value of +5 is 5. So basically, because of this fact that either of these could produce that singular answer, then what we're going to have to do when we take the absolute value of, for example, the absolute value of x equals 5, let's use a different number, 8. Then if we get rid of the absolute value signs, then our answer has to be plus or minus 8, because either a +8 would give you this answer or a -8 would give you this answer. Okay? This is the same way that when we took the square root of both sides, we had to use the positive or negative. Same concept. Well, here's another example. X equals the absolute value of 4. Well, it could be, x could be -4 and x could be +4. Okay, so the absolute value of -4 is 4. The absolute value of +4 equals 4. When I wrote that, I tried to do it on my tablet, and my tablet was wiggling a little bit. My penmanship's bad enough to start with, so that didn't help. All right, we need to solve this equation. In order to remove these absolute value symbols, when we remove them, then we have to give the plus or minus. Now, that generates two different questions, two different problems to work. This will always work out this way. I've got this one using the positive value, and I've got this one using the negative value. This one simplifies and solves to x equals 3. This one simplifies, and I'm not done yet, to x equals -2. So anytime you have this plus or minus, that means you're actually going to have two separate problems to work. And then there would be your solution set on this problem. Okay, here's another one. This time we've got some steps to undo before we can actually remove the absolute values. It's going to be one of the later steps. We got to get this 1 on the other side. Then we need to divide both sides by 2. So I took the 1 to the other side, subtracted 1 each side, gave me the 6. Now I'm going to divide both sides by 2. Okay, the 2's here would cancel, and here I would get 3. Now I'm finally ready to take the absolute value of both sides and remove the symbols. So I remove those, and then I have to have plus or minus 3. Now, here's my two equations that generates. X minus 4 equals +3. X minus 4 equals -3. With the two respective solutions. If you put 7 into this problem, or if you put 1 into this problem, you will get a correct true answer. And there's your solution set. Now, what this symbol right here, what this symbolizes, let's translate math speak. Okay, we got absolute value of something equals a number. If that number is less than 0, meaning it is a negative number, then there is no solution. That's what this is saying. So, why? Well, the reason why is absolute value of 5 equals 5. Absolute value of negative 5 equals positive 5, right? Well, there is no way you could have the absolute value of either one of these and get an answer of negative 5. This is not possible. And that's why this is saying if this is a negative number, no solution. Now, that's a shortcut for you. You see that situation where you have an isolated absolute value and a negative on the other side? Answer is automatically no solution. Now let's look at a problem. X plus 2 equals negative 3. What if we didn't recognize that? X plus 2 equals negative 3. Okay? Well, if we tried to get rid of these absolute values, we're going to have a plus or minus negative 3. Okay? Well, let's carry this thing on out. X plus 2 equals negative 3. And x plus 2 equals a positive 3. Okay? Minus 2 minus 2. X equals negative 5. Okay? Now, let's check this. Negative 5 plus 2 is negative 3. Absolute value of that. But the absolute value of negative 3 is positive 3. So this can't be true. So that one can't be true. And we could do a similar test with this one, and we would see that it also wouldn't be true. Absolute value of positive 3 plus 2 equals negative 3. And in this case, we would be getting a ridiculous statement like that. So as you see, neither answer would be true. So I look at this problem up here and I see that negative and I just know no solution. Why go through all that bother? And I just answered the why for you. Okay, solve more equations. What if this value is 0? Well, this is just saying then that's got to be 0. Okay, here's the problem. We've eliminated this. You can say plus or minus 0, but 0 has no sign. So we've only got one equation this time. and x equals -2. Well, that does give us a valid answer, okay? Because we can test this. -2 plus 2 is 0, and absolute value of 0 is 0. So you can, if this is 0 over here, get a valid answer. Okay, here are a couple of more problems. Five times absolute value of 2 minus 4t equals 50. Okay, so first thing I want to do is divide both sides by 5. Absolute value of 2 minus 4t equals 10. Get rid of the absolute value sign. 2 minus 4t equals positive 10. 2 minus 4t equals negative 10. So there's my two equations. Subtract 2 on both sides. Negative 4t equals 8. Divide by -4. And t equals -2. Better make that negative a little more obvious. Over here, -2 minus 2. Negative 4t equals -12. Divide by -4. T equals positive 3. So my solution set then is going to be -2, positive 3. Okay? And both of those, if you substitute it in there, you will get a correct answer. Now let's work the other problem. 5 equals absolute value of 6c minus 7 plus 9. I've got to get rid of this add-on first. So I subtract 9 on both sides. And I get -4 equals absolute value of 6c minus 7. I take off, I get a plus 4 equals 6c minus 7. And I get a -4, excuse me. Whoa. What have I got here? I have a negative value equals an absolute value. There's my answer without going any farther. So you always want to look for those things that can save you time. Because I know I haven't told you this before, but I have a famous motto. My famous old saying is work smarter, not harder, for Carter. So here we recognize this, so we work smarter instead of going ahead and trying to work that whole thing out. What if you have two absolute values? Well, it absolutely doesn't make any difference how you solve the problem. You still take the same approach. Let's look at this one. Absolute. By the way, I hope you guys caught my weak pun there. Okay, we don't have any add-ons to deal with. So we've got 3x minus 1, we got rid of that, equals plus or minus parentheses x plus 5. Okay. Now, this in turn produces two equations. The only difference is we're going to have to do some grouping in here when we do our plus or minus. Well, this isn't going to change any. So I can take this x over the, I'll rewrite it, 3x minus 1 equals x plus 5, because that plus sign's not going to alter anything. We'll take this over there, and we'll take that over there. So minus 1, minus x, and then plus 1, and I get 2x equals 6. Divide by 2, x equals 3. For this one, 3x minus 1 equals negative x minus 5. I have to distribute that negative both places. Okay, now I'm going to add a positive x to both sides to get this over here. And then I'm going to add a positive 1 to both sides here. 3x and 1x makes 4x. Those go away. Those go away. And here I get negative 4. Divide by 4, x equals negative 1. Okay, so those are our two individual solutions. And then our set notation would be 3, negative 1. Okay, here's another problem with absolutes on both sides. What's the problem with what they've done? Ah, there we go. They just took it as, instead of showing a plus or minus around a parentheses, they just wrote it out individually into your two steps or your two equations. This problem is essentially the same as the last one that we had. Okay? We had one to both sides. Actually, this is the same one we just had. Except their writing's prettier than mine. Okay, here are two more problems. I think I'll work problem B because it looks scarier than problem A. So let's try problem B. Four plus x equals plus or minus negative 4 minus x. Okay, I removed the absolute values on both sides, but I know that I've still got to distribute those. So my two problems, 4 plus x equals the positive of negative 4 minus x. And then for the negative side, 4 plus x equals negative times negative is positive. Negative times negative is positive. So there's my two equations. In this case, plus 4, I get 8. And if I want to take the x over to this side, it doesn't matter which direction, minus x, I get negative 2x. divide by -2, x equals -4. Okay? What about this side? You know what? I've got the same thing on both sides. Now, I could move stuff to one side or the other, but as soon as I see I've got exactly the same thing on both sides, that's an identity. Any real number will work. Okay? So, what is my solution set? Any real number. Okay? Why didn't I write this one separately? Because that one includes this one. Now, I want to warn you to watch out when you're doing the homework for how Alex is going to treat that. Okay, now we're going to use rational exponents. That means fractional powers. Here are the steps. First, we're going to do radical rather than rational. I stated, I didn't read what it wrote. Radical is another word for square roots. And a radical is the symbol. So, we isolate one radical on one side of the equation. If there's more than radical, choose one of them to have on the left by itself, and then anything else in the problem on the right. The second step, if it is a square root, square both sides, okay, equal to the index of the radical. If it's a cube root, then you cube both sides. If it's a fifth root, you take both sides to the fifth power, whatever it takes to get rid of the radical. And then solve the remaining equation. Now, sometimes if you end up with radicals on both sides, you're going to have to square both sides, cube both sides, whatever, multiple times. Then check your solution to see if they work in the original problem or if you have a domain issue. I'll leave that up just for a moment in case any of you want to write it down. All right, let's go on. In solving radical equations, extraneous, meaning ones you don't use, solutions potentially happen when both sides of the equation are raised to an even power. Now, notice this doesn't say to an odd power like cube. This is an even power like second, fourth, sixth, and so on. Therefore, an equation with only odd index roots will not have extraneous, unreal solutions. However, it's still recommended that all solutions be checked. So what it's saying is when you have a square root or a fourth root or a sixth root or an eighth root, you better check on your extraneous equations, or solutions, I mean. Okay, we've got this problem. We've got an add-on with the radical. So we've got to get that 3 on the other side first, which we did. We just added -3 to both sides. Now, the next step I'm going to do is I'm going to square this, because if you square a square root, you get what's ever inside it. But if I square this, I have to square this whole problem. So there's my step shown for this. This results in just x minus 1 over here, but this is not x squared minus 9. This, you have to FOIL it and get x squared minus 6x plus 9. Now we're going to combine like terms. We move this x and this 1 over, leaving 0 on this side. You could have put the 0 on the other side, it doesn't matter. So now let's see if we can factor this. Well, what are the factors of 10? 1 and 10, 2 and 5. 2 and 5 make 7 because you're going to add with the rule of signs. So this factors into that, and they're both negative. So my two solutions then are going to be x equals 5, x equals 2. Now I have to test those and see if they give me a truth. Okay? So let's look at the two checks over here. The first check, I'm going to try the 5. I replace the x with 5. 5 minus 1 is 4. Square root. Okay, they left out a step. This gives you square root of 4, which is 2. And then you've still got that 3 add-on, and 2 plus 3 does equal 5. So that one checks. Now let's check the 2. There we go. Okay, I put this in here. 2 minus 1 is 1, square root of 1. Okay. So square root of 1 is 1. It extracts and gives me that. And I get 1 plus 3 is 4. And that's not the same as 2. So that's what we're calling an extraneous answer. An answer that won't check out in a valid manner. But you'll only have that when you square both sides, 4th power both sides, 6th power. Not if you use 3, 5, 7, and so on as your power. I see one place I've still got to erase. Okay, what about this one? T plus 7 equals t minus 5. I've already got my radical isolated, so that makes it pretty easy. So what I need to do now is I need to square both sides, square that, and square this. That gives me t plus 7 over here, and this gives me t squared minus 10 t plus 25 when I FOIL it. What I did was that. Now, let's start combining terms. T squared, I'm going to add a negative t and a negative 7 on these, and a negative t and a negative 7. So here I get negative 17 t, and here I get 15 minus 7 is 8, so 18 equals 0. I try to factor this. They're both going to be minus. So let's see. That tells me I'm going to add my powers of this one. 6 and 3 make 9. 9 and 2 make 17. Let's see. My choices are 1 and 18. And 2 and 9. and 3 and 6. And those are my choices there. Let's see if this thing will factor. Well, have I made any mistakes anywhere? Yes. How in the world did I get negative 10t minus 1t is 17? Let's try an 11 here, and it might be right now. Okay. Well, I'm going to add, based on that, 9 and 2 makes 11, so 9, 2, and put in the t's. Boy, it's easy to make careless little mistakes on these. So 0 equals those, so this gives me the two solutions. T equals 9, and t equals 2. I have to test them to see if they would be true. Square root of 9 plus 7, which is square root of 16, equals 9 minus 5. I'm thinking ahead. And square root of 16 is 4, so that one checks. Now let's check this one. Square root of 2 plus 7, which is square root of 9, which is 3. Over here, I get 2 minus 5, which is negative 3. So here, I get an incorrect solution. Okay? Because 3 can't be negative 3. Okay, now we've got something new thrown in here that's really kind of ugly. So I made some kind of an error. Okay, so far they're exactly the same as me. So far they're exactly the same. Okay, somewhere between here and here, I made an error. I wish I could go back and look at what I did. Okay. I'm not sure. I think I made my error on this step right here. I'm not sure. Well, anyway, they distributed the 16. Now they're going to combine like terms. And I had a 26 here. And I don't know where I came up with that 7 a minute ago. I wish I could see what I did before. But at any rate, this thing factors into x times x plus 24, so your answers are negative 24 and 0 are your answers here. Then you'd have to go in and try 24 and 0 in that original problem. Okay, here they're continuing it. They're factored out the x from both sides. There's your two answers that I told you. And they're going to check it, and the 0 won't work. Okay? The 48, or the negative 24 rather, does work. Okay? This is due before class tomorrow. Now, I've given you the list of problems both on the bottom of the record sheet, except the one on the record sheet, you drop out problems 3 through 7. And then it's also listed under the assignments tab in Blackboard, not Alex, in Blackboard. You need to work these. You need to show your work on separate paper. If you want to write your answers on this sheet, that's fine, but you need to show your justification work on the other paper. Now, what's going to happen in class tomorrow with this? We're going to go over all of the answers for them. If you got a problem wrong, I would encourage you to write down the correct answer, then go back and rework it at your scratch paper so you can still get full credit for it tomorrow night. These have to be submitted in PDF form, by either scanned or pictures put into a PDF by 10 p.m. Friday night. So we'll go over them tomorrow in class. If you made a mistake, you can write down the correct answer, because all I'm going to do tomorrow is read off the answers. Then you can rework